Okay, today I'm going to be lecturing on the last two sections. So for DMA 60, this is going to be sections 13 and 14. 13 is not going to be like a lot of new information. In section 13, what we're going to do is we're going to solve quadratic equations. What we've done so far is we have factored quadratic equations, but we have not given a solution. So the only new piece that we're going to have is given a solution. So I'm going to start with a simpler way to do this. You will begin and they will give you problems where you have a quadratic that has already been factored. So this is a situation where this polynomial was factored into this and it's set equal to 0. So the quadratic technically is ax squared plus bx equals 0. So what you would do is you would do whatever factoring and set it equal to 0. Then we're going to give solutions of what x is equal to. So in this case, since this is already factored, this first m technically is just equal to 0. If I could cover this up and that didn't exist, you just have m equals 0. To solve for this parenthesis, you would take 3m minus 1, set it equal to 0, move the 1 over, 3m equals 1, divide both sides by 3, and m is equal to 1/3. So my solutions to this would be a 0 and a 1/3. I would have two solutions for that. I'm going to give you another simple one that is already factored. We're going to take y minus 6, 2y plus 7. It is set equal to 0. So this is already factored. I'm going to take the y minus 6, set it equal to 0, and take the 2y plus 7, set it equal to 0. So here, move your 6 over, and y equals positive 6. Here, I would move my 7 over. 2y is equal to negative 7. Divide both sides by 2. Y is equal to a negative 7 halves. So when you give your answer for this problem, you're going to give it as two numerals. Do not put parentheses around them because it is not a ordered pair. It is two solutions of what makes each parenthesis equal to 0. Now, you will ultimately have a problem such as this: x squared minus 5x minus 24 equals 0. So in this, you're back to solving quadratics like we've done in the past. And I'll review that in just one second. So let me pull up the calculator. If I go to y equals, notice I already have y1 plus x on the second row. On the first row, I'm going to do, I believe mine was negative 24 divided by x, second table, and my middle number is a negative 5. So I'm going to let my I come to the third column. Here's my negative 5. So my two solutions to factor are a minus 8 and a positive 3. A minus 8 and a positive 3. I have now factored this. You can do one of two things. I want you to get into the habit when you have it written in this form, you should be able to look at this and ask yourself, what makes this parenthesis equal to 0? A positive 8. 8 minus 8 would make that a 0. So 8 would be a solution. What plus 3 gives me 0? That would be a negative 3. But if you're still not sure how to do that, what you're doing is taking the left parenthesis, set it equal to 0. So when you move your 8 over, x equals positive 8. Here, x plus 3 is 0. Move your 3 over, and x equals negative 3. So once you factor, just as we've done in sections 9 through 12, you then are given a solution of what makes each factor equal to the 0. Let's do another one where we get to also practice a little more factoring where we have a leading coefficient. So if you recall, when we factor 1, it's in the right order. They're going to start with x. And when I do y1 and I multiply a times c, I'm going to end up with negative 12 divided by x. 4 times negative 3 gives me negative 12. This is where you need to remember on your paper to go ahead and write the divided by 4 under where both answers are going to go. Let's remember our middle term is negative 11. So let's go to our calculator. On y equals, I have negative 12. Oh, hang on, I hit a wrong key. Negative 12 divided by x, second table, and I'm looking for a negative 11. So my answers are going to be a minus 12 and a plus 1. A minus 12 and a plus 1. So what we do here is 12 divided by 4 is a whole number, 3. Now for this one, in this section 13, do not do bottoms up. Leave it just like it is. It's going to make the math a little easier. If I took x minus 3 and set it equal to 0, move my 3 over, x equals positive 3. Here, if I take x plus 1/4, set it equal to 0, all I do is subtract 1/4 from both sides, and x equals negative 4. When you give your final solution, you just list these two numerals. Order does not matter. Just use a comma to separate the two. Now, not all of the problems will be in the correct order. Sometimes you'll be given problems, and let's say we have this. 5y squared equals 20. So when I look at this, it's not set equal to 0. So if I move my 20 to the left side, I would have 5y squared minus 20 is equal to 0. For this problem, I have a greatest common factor of 5. That's with y squared minus 4. I can now factor this into a difference of squares. If you did the calculator, it's negative 4 divided by x, and you're looking for a 0 because there's no middle term. But when you recognize it's a difference of squares, it's a plus 2 and a minus 2. So my solution for this problem would be, what makes this parenthesis a 0? A negative 2. What would make this parenthesis a 0? That would be a positive 2. What if you have something that has more than 2 variables? For this particular problem, let's look at this. 2y cubed minus 18y. So the first thing is I'm going to move the 18 to the left, so I have to subtract it to move it to the left side of the equation. Here, when I look at this, they both have in common a 2 and a y, which leaves me with y squared minus 9. I can't factor the 2y at the beginning anymore, but the middle term would be a difference of squares. So in case you don't remember how to do that, let's do one of those as an example. I have negative 9 divided by x, second table. Since there was no middle term, I'm looking in the third column for a 1, so for a 0, so let me scroll down a little bit. Okay, so once I find the 0, if it'll stop moving, what I have here is a positive 3 and a minus 3. So that's what I'm going to use, and my problem is I'm going to use a y plus 3 and a y minus 3. So my solutions here would be for 2y being equal to 0. If I divide both sides by 2, I'm still left with y equals 0. What makes this equal to 0? A negative 3. And what makes this equal to 0? A positive 3. So that's all of section 13. Either your problems will already be factored and you set each factor equal to 0, or you factor the polynomial, and once you have factored it and have it set equal to 0, you give the solution of what makes each part equal to 0. Now, At this point, we have done a huge amount of factoring, and I want you to be able to take a little bit of a break. So as we do section 14, I'm going to show you some calculator steps to solve these problems. If you click on the view an example in one of the workbook problems, it's going to take you through the long way to do this. I'm going to show you what will be the simplest way to go about solving. Okay, so let me begin with, let me give us a word problem. Here is our word problem. It says the sum of a number and its square is 132. So when we have one of these word problems, the first thing we're going to do is write an equation. The sum means we're going to add something. We're going to find the sum of a number and its square. So the number is x. Its square is going to be x squared. We know the word is means equals 132. So I first just write my equation. Now, I am not going to have you redo this and do all the factoring like we've done in all the previous sections. What we're going to do is we are going to set the left side as y1, and we're going to use the right side as y2. So that means on your calculator, we're going to type these in on y1 and y2. So on y1, I'm going to type my x plus x squared. On the second row, I'm going to type in the number 132. So do you see the left side of the equation I put on the first row, the second equation, part of the equation I put on the right side. Then we're going to press graph to view it. I'm going to need to show you some zooming that we're going to have to do. We're always going to start with zoom and number 6. So I'm going to let that be loading, okay? So once we write the equation and we set the left side as the y1 and we do the right side as a y2, we're going to press graph to view it. After we press graph to view, these are the zooms that we're going to use. We're going to start with zoom 6. If we don't see the point of intersection, we then do zoom 0. If we still don't see the point of intersection, we do zoom 3, enter. What we are doing is, I'm going to make note here, stop zoom when you see where the lines cross, because that's what we're looking for, is where they intersect. Once we see where they intersect, we're then going to do second trace, and we're going to choose number 5, and we're going to move the asterisk to point of intersection. Once you get to the point of intersection, you're going to press enter 3 times. That will then give you the answer. Okay, so let's come back to the calculator. We did zoom 6. This is our standard view, but I'm only seeing one line. It's blue. So now I'm going to do zoom and choose the option 0. And then we're going to let it load. Here comes my parabola. And in a moment, I should hopefully see a red line appear on my screen. Oh, now do you see my red line is appearing here at the very tippy top? I still can't see where the two cross. So now I'm going to do zoom 3. Now, if you just do zoom 3, it doesn't move. You actually have to press enter. Now, here's our parabola again, and this is beautiful. We can see where it intersects. Now, this problem is not a word problem talking about the length of a table or some finite measurement. This is a numeral problem. So we're going to need to give two answers, where it intersects here and where it intersects here. So second trace number 5, I'm going to start by moving my cursor to the left. It doesn't have to be perfectly on it, just somewhere near it. Then press enter 1, 2, 3 times. You keep pressing it until this word here says intersection. So it intersects at the number -12. So one solution is going to be -12. And I have to repeat this again. Second trace number 5. And now I'm going to move the cursor to the right side. You just have to be patient. It takes a moment for me to get it to move over. Okay, so now that it's near, I'm going to press enter 1, 2, 3 times until I see this word intersection. The other answer is a +11. So for this particular problem, that happens to be both of my solutions. Now, some of these problems that we have are going to be word problems more complicated than this. So let's move into another word problem. And for this word problem, we're going to have, they're talking about the length of a rectangle. Draw a rectangle, and I'm going to label this. It says the length of a rectangular rug is 2 feet more than the width. The area of the rug is 48 square feet. Find the length and the width. Okay, so if the length is 2 feet more than the width is going to be the x. The length is 2 feet more, so that will be x plus 2. They tell me the area is 48. Now, to find the area, we would multiply width times length. Hang on a second. Equals area. So when I plug this in, I'm going to do width is x, length is x plus 2, and the area is 48. So as I said a moment ago, what we're going to do, we're going to type in this side on y1, we're going to type in this side on y2. Okay, so let's go to our calculator. Clear. I'm going to have x parenthesis x plus 2. On the second row, our area is the value 48. So here's the left side of my equals, here's the right side of my equals. Then we press graph. Now notice we're not at the beginning view. We don't see all those perfect tick marks. After you let your page load, even if you can see what you need, please don't use it here. I want you to learn this process of how to zoom, because when you take the test, you need to know how to go about moving around with the zoom. So we start with zoom 6. I don't see both lines, so I do zoom 0 second. Here's the parabola, and up. So now I can see this one very well. Now this is about talking about the length of a rug. So can we have a negative length? Because you know to the left of the axis, these would be negative answers. So we're not going to use the answer, the intersection for this side. We're only going to get the answer that's positive on the right. So we do second, trace, choose number 5, intersect. And we're going to move our cursor to the right. Once we're somewhere near, we press enter 1, 2, 3 times until we see the word intersection. X is equal to 6. So when I come back here, X equals 6. So 6 is going to be the width. X plus 2 means 6 plus 2 would give me 8. 8 is the length. And if you check your work, isn't 6 times 8 equal to the 48? So I hope you find as you work with these problems that you'll find them to be a little bit simpler to do. Let me jump in here and do one of these that has consecutive numbers. Find the product of two consecutive even integers, that is 528. Find the two numbers. So what we have is we're going to use two consecutive even integers whose product is 528. So thinking back to a prior DMA, I'm going to do my think and my use. Two consecutive even numbers would be 2 and 4. If x is 2, then 2 plus 2 is what would give me 4. So we're going to have x times x plus 2, product means you multiply, is equal to 528. We're going to then type in the left side on Y1 and the right side on Y2. So just go to Y equals, hit clear. So we're going to have x parenthesis x plus 2. And for this one, it's going to be equal to 528. Graph. I'm going to go back at the beginning after this loads. And you always have to let it load or your whole calculator is just going to kind of lock up on you. So we're going to let that load. And then I'm going to start with zoom 6. And then I'm going to now move into zoom. Okay, now I can do zoom 0. Can't quite see where they touch. So we're going to do zoom 3, press enter. Now I can see what we need, and we're going to use the length on this side. So we're going to do second trace number 5, move our cursor to the right, and press enter 3 times. And once we see the word intersection, we know that our solution here is going to be 22. So here, x is equal to 22. I want to give you one last problem, and this one is going to be just like one of your test questions. This one is going to have you apply using the Pythagorean theorem. So let me sketch a picture here. We're going to have a ladder that is leaning against a building. Here's the ladder with the rungs. And we want to know the length of the ladder. So the ladder is going to be labeled X. You're going to be told that the distance from the bottom of the ladder to the building is 6 feet. And you're going to be told that the distance from the base to the top of the ladder is 2 feet less than the length of the ladder. So we're going to use our Pythagorean theorem, which is a squared plus b squared equals c squared. In case you don't remember what was the a, b, and c, the two sides that make the 90-degree angles are the a and the b. The diagonal, which is the ladder here, that is our C. Something that they do not mark, and I want to be sure when you write yours down, you use a parenthesis around the x minus 2. So my A would be 6 squared. My B would be x minus 2. Put it in a parenthesis, then square it. And C is the letter X, and we're going to write that as squared. We're going to type this on Y1. We're going to type this on Y2. Okay, so let's key this in. So on Y equals, we're going to clear here, and we have 6 squared plus parenthesis x minus 2, close your parenthesis, squared, and the x squared is the c squared. So take a moment and make sure you have that keyed in. We're going to do graph to view it. After I press graph, I'm going to start back at my Zoom 6. So let's let it load. Okay, so we begin with Zoom 6. And we do not see all of what we need. So now we're going to do Zoom 0. I see both parabolas. I can't quite get to where they intersect, so I'm going to do the next one, Zoom 3, enter. Zoom 3, enter. Now that I can clearly see where they intersect, right in here, I'm now going to do second, trace. Okay, hang on one more time. Second, trace. There we go. Number 5, I'm going to move my cursor over near where I see the intersection. I'm going to press enter 1, 2, 3 times until I see the word intersection. My answer for X is 10. So that means here the length of the ladder is going to be 10 feet. Okay? So as you're working through section 14, you're going to set each equation equal to y1 and y2. You're going to go to the graph to view it. Do your zooming until you see where the lines intersect. Then do second trace 5 to get the intersection of lines. So no matter how big or complicated your problem may look, you don't have to combine like terms, you don't have to factor, you just write the equation and then key that in on y1 and y2. Okay? So I hope this helps. Thank you.